Hello, welcome back. Now the second problem, I forgot to show you that I did graph it. So if you want to graph, this isn't how I would graph this. This was side length. This is perimeter, so you can put that in your calculator is what I did. Use my scale, and you'll see that your minimum value on that number 2 is 31.6, 126.5. All right, now let's do number 3. If 1,200 square centimeters of material is available to make a box with a square base and an open top, find the dimensions of the largest possible volume of the box. What is the maximum volume? All right, so largest possible volume. Remember, we're working at optimization, so this is a maximum. We want to maximize volume. Look at number 3. Maximize volume, and we're talking about a box with an open top here. So there's no top. It has a back and a front and 2 sides and then a bottom. The volume of a box is length times width times height, and it says that it has a square base, so my base is x by x, and this one's some y value that may or may not be the same as x and these two x's. So my length times width times height, x times y, gives x squared y. And this is your primary equation, because that's what we want to maximize. And notice again, we got the x and the y. So I need to find another equation for y and plug it in so that I have v as a function of x only. Now, there we're given 1,200 square centimeters of material is available to make the box. So we are making the box of maybe cardboard, and we get 1,200 square. Now notice that's an area. So we're going to think of it as wrapping paper, wrap everything but the top, or you can think of it as just the material to make the box. And I wrote over here, the box with open top has 5 faces. There's the front and the back and the 2 sides. So what I did was I stretched out this box. Actually, I flattened it. And it has 1, 2, 3, 4 sides. Now, if you look at this face, they're actually called faces. This is an x by y, but you'll see that this side as well. So if I look at this, what's called a face, is xy. And the back one's going to be xy, and the left side's going to be xy. But look at the base, it's an x by x, okay, the bottom of the box. So what I did was I wrote xy, xy, xy on all of those. So on the 4 faces that go around, and that area is x times y, and there are 4 of them. And the bottom is x times x, and that area is x squared. So total area would be all of that, so there's all the material, plus that. So all 4 faces here, plus the bottom. So what I wrote is that the area is the bottom, I put x squared, plus 4xy, because there are 4 of those. And set that equal to 1,200. Okay, now I'm going to solve for y, so subtract x squared and divide by 4x. Now I'm going to simplify this. Actually, I'm going to go ahead and plug that into, you go back up here, plug it in for y. So I get b equal x squared times 1,200 minus x over 4x. One of the x's cancels here, and I just have an x here. Then I distribute it, and I got 1,200x minus x cubed over 4. And I thought, well, that's a constant. I'm not going to do quotient rule with that. So I just divided each one by 4, each term. And then I turned it around and wrote v equals negative 1/4 x cubed plus 300x. I'm just trying to prepare it to take a nice derivative, an easy derivative. Up here, that's not, I'm going to simplify it as much as I can. So look, that's going to be a pretty easy derivative. I bring the 3 in front, I get negative 3/4 x squared plus 300, set that equal to 0, bring the negative, divide, take the square root, and plus or minus, but in this case we're talking about the length of the base. Okay, so the x I get is 20. And then I plug in and I get my y is 10. And then I plug in to get, what am I looking for? Volume. So the volume goes back here. You can just go x squared y. So the dimensions are 20 centimeters by 20 centimeters, right? Because if I come up here, this one's 20 centimeters. This one's 20 centimeters. And then my y, what was it? I plugged in to my y equation and got 10. So this is 10 centimeters. And those are my dimensions, 20 by 20 by 10. So I'm going to write that down. The dimensions are 20 centimeters by 20 centimeters by 10 centimeters. And the volume, the maximum volume, is 4,000 cubic centimeters. Because what you do is you just take 20 times 20 times 10. That gives you 4,000. And then centimeter, centimeter, centimeter. Volume is measured in cubic centimeters. All right, I will be back for number 3. Actually, number 4.